Image impresarios and picturesque Pythonistas, it's Prof G, and in this lesson I'll show you how to get images ready for use with CircuitPython. We'll size images properly, we'll show you how to add and proportionally size a background for an image, and we'll save an image using the proper BMP format that CircuitPython wants. And we'll do all of this using free software called GIMP. It's available for Windows and Mac, and it has lots of features that you'd find in commercial products like Photoshop and Illustrator. What's the big picture? It's all about big learning. Now, we do use concepts we learned about in previous lessons, so if you're new here, welcome, but you may want to check out the playlist to see how we got here. So friends, we're going to use files that we downloaded in our prior lesson on displaying images in CircuitPython. You may have these files already downloaded, but if not, here's a URL for a GitHub repo that's got the files you'll need, and this is also linked in the description. So if you head to this URL, just click the green code button and select download zip, and then find the file that you downloaded, uncompress it if you need to, and you'll be ready to go. This folder has an images folder inside it that contains 2 BMP images that we used in our earlier lesson. If you completed that lesson, you probably already got this images file in your CircuitPy volume. If not, copy it over. And we also use the fonts folder from that lesson. Make sure you got the fonts folder copied over too. Then you can close up your CircuitPy volume, because what we're going to be focusing on in this lesson is working with files that aren't ready for CircuitPython. So in a folder named Downloaded Images, you've got 4 photos that I took while on sabbatical in Australia last year. I was teaching at UTS in Sydney, but Apple Australia kindly flew me all over to lecture on best practices in STEM education, and I took some time to scuba dive and explore. So the wildlife down under is the subject of these photos, and we'll convert them for use in our display. Now I'm using a 320 by 240 display. You can resize these files using the techniques shown so that they can properly fit any size display you might use, but you should do the resizing before you drag the files over to your board. We usually try to minimize heavy onboard work like resizing files or saving large files to our board, since the resources for microcontrollers are so constrained. Now, to make sure everyone can follow along and to save my students a few bucks, we're going to be using free software available for Windows or Mac. It's called GIMP, and it's excellent. Many people use this instead of commercial and expensive alternatives like Illustrator and Photoshop. If you don't have GIMP, head to gimp.org, G-I-M-P, and download the version appropriate for a computer, then come back and we'll work together. So open up GIMP, head to the File menu, select Open, and then navigate to the CircuitPython image loading demo main folder that we downloaded from GitHub, and find the Downloaded Images folder. Get inside of that. Then find and double-click quokka.jpg. If you don't know the quokka, they're known as the world's friendliest animals. They look like they're smiling. I met this guy just outside of Perth in Western Australia. Now, this is a very large image. What I want to do is crop it so that we can focus on the quokka's face, and I'd like to shrink it down so it's a 320 by 240 image. That's the size of my display. So first I'm going to create a crop rectangle that's got the dimensions of 320 by 240, the dimensions of my display, and I'm going to do this by clicking on this crop tool in the upper left, and now down below this there's a pull down that in my software says fixed aspect ratio. Now I might say that because I've used that option before. If yours doesn't say fixed aspect ratio, pull down here and select that now, and then inside this field below, sometimes you have to hold your cursor over it and wait a second to click, or click and then wait a second. GIMP is fuzzy sometimes, and you should be able to get in here and change any values that are in there. I'll set this to 320:240. Those are the dimensions that I want to use, and then I can move my cursor over and draw a box. Now this is going to keep the 320 by 240 aspect ratio. That just means its width relative to its height. Although depending on where I drag, it might make this a larger or smaller box, but I'll position this right around this little cutie's head, and then once you've got it exactly where you want it, double click inside the crop rectangle, and the image will be cropped. Nice. Now I want to scale this image to 320 by 240, and I can never remember where that menu item is, but if you go up here to the Help menu, pull down, and then type Scale into the search box, I can see the first item that shows up is Scale Image, and if I move my cursor down or select this, I can see where it is in the menu, and if I highlight this and just press Return, that'll select that item for me. Now a Scale Image box pops up, and the width and the height that you see here has the aspect ratio, so the ratio of width to height is what we want, but this image is way too big. But if I change the width to 320, look at this, the height is automatically scaled down, keeping the proportions the same, so it's 240, that's exactly what I want. So I'm going to click on Scale, and our image is now shrunken down to 320 by 240. You can pinch and zoom to look at this, but this is what I want, so let's save this as a BMP file. And to do that, just head up to the File menu and select Export As. as. Now in most software you select a file type, but GIMP lets you just change the file extension. So I'm going to backspace over JPG. This was a JPEG file, and I'm going to replace that with .bmp. Make sure you've got the dot in there, and I'm going to make sure that this file is named Quokka with all lowercase letters. Remember that since we're going to use that name in our code. Then I'll click Desktop over here on the left so that I save this file to the desktop, and then click on Export. And we'll get another dialog box that asks us for some additional settings. And under RGB format, you want to pull down here, and the selection you want for most TFT and OLED displays is 16-bit R5G6B5. So that's 565, and then click Export, and that should be it. Now I'm going to quit GIMP, and I'm going to make sure that I save this properly. I don't need to save the image I was working on because I've already exported what I want, so I'm going to discard changes here. My export has already happened at this point. And if you're on a Mac, you can double-click on the quokka.bmp file. That's the file that we just created with export. Preview opens up, and I can go into the Tools menu and select Adjust Size, and I can see this is 320 by 240. That's what I want. Nice. So I'm not doing anything in Preview, so if you're a Windows user, don't worry about it. I'm just showing Mac users how they can verify the size, and this is good. So now you can open up your CircuitPy volume and drag this inside the Images folder. And make sure you drop it directly in the Images folder. You want it copied into that folder so that the code that we write can find where that file is. And then I'm going to get back into GIMP, and we're going to convert our cassowary image, and this is going to let us demonstrate some more techniques. So I'll close the Recents File dialog and head up to the File menu and select Open. Navigate to CircuitPython Image Loading Demo Main. That's the folder we downloaded from GitHub. Then go inside the Downloaded Images folder. Find cassowary.jpg, double-click that, and it opens up. Now this is asking me about the image's color profile. I'm just going to click on Keep here. Now if you don't know the cassowary, it's the world's third largest bird. These things can get over 6 feet tall, and they are vicious. This is a real animal. It's not AI. It's the closest thing we have to a velociraptor. They've got deadly super sharp front claws. You don't want to cross one. In the wild, pretty much the only place you can find them is in the Daintree rainforest near the Great Barrier Reef in Australia, in Queensland. But if you're fortunate enough to see one, they are a sight to behold. Do not get close. Now, the first thing I want to do is to scale this guy down so he also fits in my display. So I'm once again going to go up to Help and find Scale Image and select that. And this image is not sized so that it can fit in my 320 by 240 display. I'm going to keep the aspect ratio of this image. I want to show the whole image, but we'll create a black background, and in fact, we'll use the black background as contrast for a text label that we'll put on our display. So since the height is the largest size in this image, I'm going to set the height to 240, which is the height of my display. And after I type that and tab out, I can see that the width changes to 135. So to keep the aspect ratio and see the whole image, if I want the height to be 240, the width is going to be 135. That's what I want. Click Scale. Now this is tiny, so on my trackpad I can pinch and zoom and scale this up. And what I want to do is to make sure that this image will obscure anything else that's in our group behind it. So what I want to do is I want to add a black background to the right-hand side so that it fills up the 320 pixel width of the display. Then with that nice black background, what I can do is put some text over it, and it'll be nice and readable. So here's what we're going to do. I'm going to resize the canvas. So that's going to allow me to resize the image so it can take up a full 320 by 240, the dimensions of our display. Now it's not going to put anything in that extra space, but I'll do that in a bit. Right now, let's head up to the Help menu and type in Canvas, and we want the option for Canvas Size. So select that. And we see the current dimensions, which are the dimensions of our image, but we want to change the width to 320. Tab over, click Resize, and we can see this is exactly what we want. For some reason, you've got to click Resize again. And the checkerboard pattern on the right shows that these are transparent pixels. Nothing's going to show up. Now, I don't want to see any layers that are behind this, so what I want to do is add a black background. This is how I'm going to do it. Over here on the right-hand side, to the bottom of this column, you can see a list of what are called layers. Now, we only have one layer right now. That's the cassowary layer. It's got our image, but I want to add a layer with a rectangle in it. So I'm actually going to go up here to the left-hand corner, and I'm going to click on this second icon here. That's going to allow me to create a rectangle. And actually, I might not even have needed that. We can go down here in the lower left-hand corner. And if we double-click this icon that looks like a plus sign in the upper left-hand corner of a piece of paper, this allows us to create a new layer. For the layer name, I'm just going to call this Background. And then down below, there's an area that says Fill With. You can click in here, and in this menu, we want to select Foreground Color. My foreground color is already selected to black. These two squares you see in the upper left-hand corner, the one on the top is considered the foreground color, the one in the back is considered the background color. My foreground color is black, that's exactly what I want. Click OK, and what this does is it adds a layer on top of the previous photo layer that's all in black. That's not what I want, but what I can do is I can drag my picture layer, the cassowary layer, so that it's ahead of the background layer. And let's see, I'm having a hard time doing this. I'm going to click and drag the background and pull it down. And once I do that, I can see the black background is in the back and I've got my photo on top of it. Looking good. This is what I want. So now I'm going to export this the same way I did before. Under File, select Export As. I'll select Desktop to save it to the desktop. And up in the name area, I'm going to delete .jpg and replace that with .bmp. Then I'll click Export. And remember, we get this additional box to select more options for BMP exporting. The RGB option should be 16, R5, G6, B5. Click Export. This should create our file, so now we can quit and discard changes. And I can verify this is now the size that I want by double-clicking it. It opens in Preview. I'll go under Tools and select Adjust Size. I see the width and height are 320 by 240. That's great. I'll cancel and get out of this, and I'm going to drag the cassowary.bmp over into my Images folder. And oh dang, I don't have enough room. Even with a Pico 2, we get space constrained when we drag over larger image files. Now we actually don't need all the fonts that are in our font folder. Those also take up a lot of room. So let's see, we were using Helv 18 before, so I'm going to keep 14 and 24, the size below and above this, and I'm going to delete all the other ones. We actually really only need Helv B18. But with these deleted, now I'll go back out of my font folder and I'll drag my cassowary over into my Images folder. So cassowary BMP is in there, and you know what, just for consistency, I'm going to rename this cassowary with a lowercase c. Nice. Now let's get into PyCharm, write a little bit of code, and see these images on our display. Now I'm going to go through this quickly because we've already covered these topics. I've got the image-display.py code up here from a prior lesson. If you don't have that, you should have saved it in your CircuitPython school folder. You can open that up right now and copy it out of that file and paste it in here if you need to. And when we ran this code before, we had a delay of 5 seconds showing each file. I'm going to speed that up a little bit, and I'm actually going to create a constant so we can change that. Just underneath where I set my backlight, that's where I'm done initializing my display. And just before I create my first group in displayio.group, I'm going to create an all caps delay constant. I'm going to set this equal to 3. Then I'm going to copy the delay and I'm going to paste it over the 5s that are inside of all of the time sleeps here after I append and show each of these different objects, and also into the 2 time sleeps that I've got in my while true. So now let's load up another image, create a bitmap, and create a label for it. So I'm going to highlight all the stuff I had for my cuttlefish from where I have the group append cuttlefish label all the way up through. This first comment here that's just above the call to on-disk bitmap, I'm going to copy this, then head below, just below where I have my group append CF label, paste this in, and let's make some changes so we can read in our Quokka. So first I'll change the bitmap name to q_bitmap. And I want to read in the string /images/quokka.bmp with a lowercase q. Make sure you spell that properly. And there are 3 areas in the line below where I referred to cf_. I'm going to change all 3 of those values to q_. Then I'll change my label name to q_label. I'll change the label's text string to Quokka. And you know what? Instead of putting this right in the bottom center, I'm going to put it in the bottom right. So I'm going to change my anchored position to just display.width. I'm not going to /2. I'll delete that. And I also want to change my anchor point to 1, 1. So that's going to start drawing from the lower right-hand corner of my display. And that'll make sure that I can see my Quokka smile without obscuring it with my label. Then we want to make sure that we append the tile grid and the label. We just named those q_, so I'm going to change those in both of the group appends down here, q_tile and q_label. And then right underneath here, I'm going to paste in the same code that I just copied and change this again for our cassowary. So let's see, instead of cf_ for cuttlefish, why don't we change all these variable names to cw_ for cassowary. So I'll change the bitmap name, the tile grid, the label to cw_label. Oh yeah, and don't forget, inside a tile grid, CW bitmap and CW bitmap pixel shader. And the string inside of on-disk bitmap, we got to make sure that that reads in cassowary.bmp. Remember that was spelled all with lowercase. And down on our 2 appends, make sure we change these so we append CW tile grid and CW label. And you know what? Instead of the standard text, Let's put a lot of text over in a right-hand column next to the cassowary, and why don't we use our wrap text to pixels function that we learned about in the last lesson. So I'm going to make some space for it up here, and you know what I'm going to do is actually go into my CircuitPython school folder, and I'm going to open up my file, wrap labeltext.py, and that's got the code that we know works for wrapping text to a certain pixel value. Now, one thing we're going to need is this import statement in here from adafruit display.text import wrap text to pixels. So I'm going to highlight and copy this, then head back over to the code.py tab, paste it in up here with my import statements. Then I'll head back to the wrap label text tab. And remember, these are the two lines that we use in order to take a string and wrap it to a particular text pixel length. So I'm going to highlight and copy these guys. Then close that outermost tab. And just above the CW underscore label for the cassowary, I'm going to paste in that code. And I'm going to change the string to wrap to read cassowary, sometimes called the murder bird. Very dangerous. And in fact, even though this is going to wrap lines for me, I want to put in a hard line feed after the word cassowary and the colon after it. I want that to look like it's the title, so I'll put a \n just after the colon and before the capital S and sometimes. And I'll do the same in front of the V for very dangerous, so that's on a separate line. So again, what I've done here is I'm going to rely on our wrap text to pixels to wrap the text in this string, but I want to make sure that I've got a hard line feed after the word cassowary and just before very dangerous. Then above this, I've got to put in a wrap width, so I'll say wrap underscore width, and that'll equal display.width /2, meaning I want to make this label no larger than half the width of my display. And I want to change my anchor point and my anchor position. Let's see, my anchor point, I want to start off at position 0. I also want this to start writing from the top, so I'm going to change my anchor position's Y value to 0. And I want the anchor point's Y value to be 0 as well. So that means it's going to go halfway over from the top, but still at the top, and it's going to start to write this label from the top left-hand corner of the label. And let me copy my time delay and paste it down below my two group appends for my two cassowary items. And now let's make some changes to while true. So this first section here is not just going to hide cuttlefish, but also quokka, and cassowary. So I'll copy my tile and my label hiddens, paste them twice down below, and change the top one to CW title, and the second one to CW label, the third one to Q title, and the fourth one to Q label. And to drive the point home, I'll also put in the comment up here, show whale shark. How does that happen? Well, if we've hidden everything else that we've added to our group, the only thing that's going to be left is the whale shark and the whale shark label. Then what do we want to do? Well, we want to show the cuttlefish. So that code's going to remain unchanged. But next we want to show the quokka and the cassowary. So what I'm going to do is highlight these three statements and the comment, copy it, paste it down below. We're not showing the cuttlefish, we're showing the quokka here. Make sure we change the tile and label to Q tile and Q label. Then copy and paste this quokka code and change it to show cassowary, where we unhide CW title and CW label. Cool. Now let's check some other things before we save and run. So let's see, most of this looks good. I'm reading in the right files. In the quokka label, I'm going to add -1 to the display width. Make sure the display height has that too. That's good to do because we're 0 indexed. In the CW label, the cassowary label, I forgot to add our wrapped underscore string as our text value. Got to change that. And this cassowary label is multi-line, so let's put in a line spacing about right below the anchor position. We'll say line underscore spacing equals, and how about 0.7 comma. And I forgot a time sleep after the appends for the cuttlefish. And I ran a test. I'm also going to jump to the fix here. I think the cassowary label's anchored position would look better if it slid over a little bit more to the left. So I'm going to subtract 12 from the X value. And I'm also going to nudge it down. I'm going to set the Y value to 20. So let's save and see how this looks. We've got our whale shark. And we have our cuttlefish. And here's a new guy, the smiling quokka with a label in the lower right. And that most dangerous cassowary, sometimes called the murder bird, very dangerous. Now in while true, we hide everything but whale shark. Then unhide the cuttlefish. Unhide the quokka. Unhide the cassowary. And continue. So Pythonista, hopefully this helped you leverage GIMP greatness for beauteous BMPs and impressive image display work. Keep coming back for more big learning, and in the meantime, make something awesome.